Hello aspirants and welcome back to another video of this channel, and today we will discuss some of these questions from NCERT. We are continuing the series to complete this hydrocarbon chapter, right? And so let's start without wasting any time, and this chapter is very important for your exam point of view. This type of questions you will definitely get, that for sure. Okay, that's for sure. Okay, so let's start. So what is given? It is given that propanol and pentanthreone are the ozonolysis product of an alkene. So there was an alkene. I don't know which alkene. Probably you have to check. You have to find out. And on this alkene, if you have done O3ZnH2O, that means if you have done ozonolysis reaction, what you got? You got propanol plus pentan 3-one. Okay, propanol plus pentan 3-one you got. What is the structural formula of the alkene? So you have to find what is this alkene. Okay, so to find out this, first of all write the structure of propanol. So propanol means prop means 3 carbon and Al means aldehyde. So it's so easy. CH3 CH2 C double bond OH. Sir, pentan 3-one means it should be pentan 3-one. On means ketone at carbon number 3 and total carbon is 5 carbon. So CH3 CH2 C double bond O CH2 CH3. These are the structures. Now I just want to give you a basic idea about ozonolysis. You already know, but if there is R1, R2 double bond C, R3 and R4, if you break it in ozonolysis, what you have to do? In ozonolysis, you have to break the double bond from the middle part. Okay, of course it is not the exact mechanism. You have to break the double bond. So if you break the double bond from the middle part, then for this carbon you see you are having R1 and R2, and for this carbon you got R3 and R4, but both the carbon is in pain because its valency is not satisfied. You have broken their hands, so it's your responsibility to satisfy their hands, their valency. So how you can do this? You can do this by adding double bond O. Right? So these two are the product. But suppose this was not given to you. The products are given. This is given to you. How can you reach from here to here? Sir, it's looking very simple. Just you take the oxygens out, this oxygen out, make a double bond between them, and you will get your alkene. So it's very easy. So now you know the thing. What you have to do? You see, this propanol is given, pentan 3-one is given. You already know their structure. Write them face to face, like oxygen face to face. If you write them and if you take the oxygen out, you will get your alkene. Let's do this in the next page. Okay, so you write CH3 CH2 CH. Okay, just give me a moment. Yeah, you write this like this: CH3 CH2 CH double bond O plus O double bond C CH2 CH3 CH2 CH3. So you see the first one is your propanol, and second one is pentan. Second one is your pentan 3-one. And if you react this, if you take the oxygen out from here, what you will get? You see, I am writing this CH3, I have written, then this CH2 I am writing, with this CH2 this carbon with the hydrogen I am writing, and this carbon and this carbon I am making a double bond because I have taken the oxygen out, so that means they will make a double bond. See, with this C, I am having this CH2CH3, I am having this CH2CH3. And sir, what about this CH2CH3? You write it like this. Okay, so this is the structure. Sir, what will be the name of this? So you do the naming: 1, 2, 3, 4, 5, 6. And if you write like this way, then this is your substituent. So the name of this is 3-ethyl hex free in, free ethyl hex free in. You see how easily you can do your question, how easily you can do your question. Now comes to this question. This is actually a very good question, but this is a easiest question. Write chemical equation for combustion reaction. What is combustion reaction? Combustion reaction is burning, or we can say reaction in presence of O2. Okay, reaction in presence of O2 of the following hydrocarbon. So I will do the following hydrocarbon at last. First we will do something like this. So any hydrocarbon, I can write any hydrocarbon like this way. Any hydrocarbon I can write like this way, CXHY, any hydrocarbon. And for any hydrocarbon, if I react this with oxygen, obviously I will get CO2 and obviously I will get water. Okay, this is my hydrocarbon. As you see, the hydrocarbon I am reacting with oxygen. That's why it is combustion reaction, because combustion is burning or reaction in presence of oxygen. So I am doing this oxygen in presence of oxygen. I am doing the reaction. I will get carbon dioxide. If it is a complete combustion, I will get carbon dioxide and I will get water. I will get water. So the thing is that how many moles of oxygen is needed? For that, the simplest calculation is x plus y by 4 moles. Sir, how many CO2? You see, C is x, so obviously x mole of CO2 you will get, and H is y, and here it is H2, so obviously y by 2 molecule of water you will get. Y by 2 molecule of water you will get. Okay, so this is your formula. Again I am writing the formula: CXHY plus x plus y by 4 O2. From here you will get x CO2 plus y by 2 H2O. Got it? This is your general formula. This is your general formula that you have to remember, or if you understand this then you don't have to remember, that's okay. Now I'll do butane. Sir, butane means it is C4H10, right? CnH2n plus 2. Yes, so butane is C4H10. Sir, for that I have to react this with oxygen. I will get CO2 and I will get H2O. Sir, how many CO2 I will get? You will get x plus y by 4. You see, C4H10, you have to combine, you have to not combine, you have to compare this with CXHY. From there I am getting, okay, let me go to the next slide, it will be better to do. So C4H10 plus O2, and from there if I react, I will get CO2, I will get water, and I will compare this with CXHY. If I compare, then I can get x value as 4 and y value as 10. Sir, how many oxygen I will get? Oxygen is needed x plus y by 4. So 4 plus 10 by 4, 40 plus 10 by 4, 50 by 4, 25 by 2. 25 by 2 moles of oxygen is needed. How many carbon said? X mole of carbon. So 4 CO2. How many moles of water said? Y by 2. 5 by 2. 5 moles of water. This is your balanced equation. Everybody is happy. Now sir, what I have to do? Pentene. You have to do now pentene. So what is the structure of pentene? Pentene means it's an alkene. Alkene, what is the general formula of alkene? CnH2n. So pentene is C5. Pentene is C5H10, right? C5H10. Okay sir, C5H10 plus O2, CO2 plus H2O. I'll compare this with CXHY. X value is 5, y value is 10. So x plus y by 4, if I do, it will be 5 plus 10 by 4. So 30 by 4. And okay, I have done a mistake, I guess. Here I have done a mistake here. Yes, sorry, I have done a mistake here. So it should be 16 plus 4, that means 26 by 4, that means it will be 13 by 2. Yeah, it was my mistake, sorry. Yes, 13 by 2, sorry, my mistake. Yeah, so it will be 15 by 2. Sir, 15 by 2, that means it will be 15 by 2 from here, 5 CO2 and 5 water. This will be my balanced equation. This will be my balanced equation, right? Then go for hexane. Hexane, sir, hexane means, first of all, it's the alkyne, and alkyne formula is CnH2n minus 2, where n value is 6, where n value is 6 because hexane, so it will be C6H10. C6H10. So sir, again the same old story, I have to do C6H10 plus oxygen. From here you will get CO2 plus water. Sir, I have to compare this with CXHY. If I compare, then I will get X value as 6, Y value as 10, then X plus Y by 4, that means 6 plus 10 by 4, that means 24, 34 by 2, that means 34 by 4, that means 17 by 2. Yes, 17 by 2. If you react, you will get 6 CO2 and 5 H2O. Same old story. Now, sir, what about toluene? Sir, toluene, I don't know. Yes, toluene, you know toluene. Toluene looks like this. Toluene looks like this. We have discussed about toluene. So toluene looks like this. That means toluene formula is C7. So why C7? You see 1, 2, 3, 4, 5, 6 and this carbon 7. Okay, you are having hydrogen at each of them. You are having hydrogen at each one of them. So 5 hydrogen and this 3 hydrogen. So C5H8 is toluene. C7H8 is your toluene. Okay, sir, then C7H8, and for that I have to react with O2. I'll get CO2 and I'll get H2O. Sir, I have to compare this with CXHY. Yes, X value is 7, Y value is 8. So X plus Y by 4, that means 7 plus 8 by 4. Said this can be divisible and you can get a 2 here, 9. So 9 O2, from here you will get 7 CO2 and you will get 4 H2O. That's it. So you see how easy these questions are. Just you have to know this formula. Just you have to know this general formula. You can do this very easily. Okay, got it? I hope you got it, and if you know, then always you are welcome. Okay, now draw the cis and trans structure of hex 2 in. Okay, so hex 2 in, I have to draw the cis formula and the trans formula. Sir, it's easy. Like we are having C double bond C, that means I can have a CH2 CH3 group here, and I can have a CH3 CH2 group here, a hydrogen here, a hydrogen here. You see how many carbon? 1, 2, 3, 4, 5, 6. But it was hex 3 in. It was hex 3 in. So it is not the structure. It was hex 3 in. So what I have to do? I have to do hex 2 in. So sir, C double bond C, I will add a CH3 group here, and I will add a CH3 CH2 CH2 group here. Yes. So 1, 2, 3, 4, 5, 6. Yeah, it's hex 2, and you see both the hydrogen I am writing on the same side. Obviously it is a cis hex 2 in. Then sir, how to write trans? You know how to write trans. Just write the hydrogen on the opposite side. You write hydrogen here, that means CH3 CH2 CH2, a hydrogen here and the CH3 here. Now you got your trans. Now you got your trans hex 2 in, right? Cis hex 2 in and trans hex 2 in. You got hex 2 in. Okay, now which isomer have the higher boiling point and why? Now you tell me which one of them is having more dipole moment? Which one of them is having more dipole moment? So as we have discussed it in detail, that cis isomer is having greater dipole moment than trans isomer. So if you ask me why it is so, because you see, in case of trans, you see this is going in this direction and this is going in this direction, so they are opposite, but and they are almost cancelling out each other. Mu, I am not saying it is equal to 0 because both the groups are not same on the ethyl and propyl groups, but we can say mu is your dipole moment, mu is near about 0. But here you see, from this side the dipole moment is operating like this, and this side it's operating like this, and dipole moment is a vector quantity, so the resultant is maybe it is going like this way. So your mu is greater than 0 and it is having a specific value. Here mu is almost near about 0. So cis isomer is having more dipole moment. What is the order I have written here? Cis greater than trans, that is your dipole moment order. Okay, and dipole moment increases, boiling point also increases. Boiling point proportional to dipole moment. There are several factors. Atomic, molecular mass, van der Waals force of attraction, hydrogen bonding, all these things are there. And there is another factor, that dipole moment depends upon the dipole moment and it is directly proportional to. So as cis is having more dipole moment, so cis is having more boiling point also. So cis isomer is having more boiling point. Got it? More boiling point. Okay, that's it. Then yeah, why is benzene extraordinarily stable though it contains 3 double bonds? So there, this benzene, these questions can be explained by the help of resonance, right? By the help of resonance. So here that aromaticity and all these parameters that will come into picture. So this is your benzene ring. But I don't want benzene ring like this way. I want to do a resonance. First of all, why the resonance is happening? Because it's a conjugated structure. Why it is conjugated structure? You see, double bond, single bond, double bond, single bond, double bond, single bond. So it's a cyclic, I can say it's a cyclic conjugated planar structure, right? It's a cyclic conjugated planar structure. So this bond goes here, this goes here, this goes here. So you can do the resonance for your life. Again it will go here, again it will go here, again it will go here. You will come back to this. So benzene ring, in that the pi bonds are continuously revolving. How many pi bonds? Said total pi bond is 3 pi bonds. I can say total 3 pi bonds. So 6 pi electrons, and 6 pi electrons means that 4n plus 2 pi electron rule satisfied, 4n plus 2 pi electron rule satisfied, where n value is 1. You can take n value any positive integer, 0, 1, 2, any positive integer. So said that means we can say it's a aromatic compound. In aromatic compound there is continuous, just a minute, there is continuous cyclic delocalizations are there. Continuous cyclic delocalization is there, and this continuous cyclic delocalization, this resonance is giving a resonance energy, and that resonance energy is helping the benzene ring to be stabilized. The benzene ring to be stabilized. From that resonance, it is evolving a resonance energy. Okay. So this is the thing from here. Then go to the next question. What is the next question? What is the necessary condition for a system to be aromatic? Just now I have discussed. The first thing is the system must be planar and conjugated. Sir, what is the meaning of conjugated? Conjugation means double bond, single bond, double bond, single bond, double bond, single bond, like that. Okay, continuous. Okay, then sir, what is the next thing? Okay, the system must be one more thing is that cyclic also. Cyclic, planar and conjugated. Okay, second thing is that continuous cyclic delocalization of electrons. And the third and most important thing is that it should satisfy 4n plus 2 pi electron rule, where this n value can be 0, 1, 2, 3, any positive integer. Okay, these three are the necessary condition for a system to be aromatic. Sir, take an example of benzene. That is very easy, that is the easiest. How many pi electrons are? 6 pi electron. So 4n plus 2 pi electron rule is satisfied or not? Definitely it is satisfied, where n value is 1. The molecule is planar, sp2, conjugated, cyclic, all are satisfied. So we can say this molecule is aromatic in nature. Which molecule? I have taken the example of benzene. Do you want any other example? Yes sir, take the example of naphthalene. Yes, you see, it's a naphthalene. If you see it's a cyclic structure, it's a conjugated structure, double bond, single bond, double bond, single bond, double bond structure, and it's a planar structure, cyclic structure. Okay, how many pi electron? You count 1, 2, 3, 4, 5. So 5 pi bonds, that means 10 pi electrons. 10 pi electrons means that 4n plus 2 pi electron rule is satisfied. 4n plus 2 pi electron rule is satisfied, where n value is 2. Definitely sir, it's aromatic. Okay sir, I understand aromatic. Take an example of non-aromatic. No problem. You see, it is also cyclic. That is okay. It is also conjugated. It is also planar. But how many pi electron you are having? 4 pi electron you are having. No way you can write it as 4n plus 2. You cannot write it in 4n plus 2. But you can write it as 4n pi electron system. 4n pi, where n value is 1, and that can make it anti-aromatic. So this aromaticity, aromatic, anti-aromatic and non-aromatic, all these things have been discussed in details. Okay, in detail we have discussed all these things. If you have any problem, you please let me know. Okay, then if you go for this question, explain why the following systems are not aromatic. If they are asking, okay, write the first molecule, and you can see that this is a cyclic thing. No problem, this is cyclic. Okay, but is it conjugated? You see, this is double bond. Okay, this is double bond, and after double bond you are having a single bond. After then again you are having a single bond. Then that means this is not conjugated. This is not conjugated, because in conjugation what you need double bond, single bond, double bond, single bond, double bond, like that you need, right? Here you see you are having a double bond, then single bond, then you are expecting a double bond, but you are getting a single bond, so it is not conjugated. If it is not conjugated, it is not aromatic. All these three has to be fulfilled, then only I can say it as aromatic. So this is not aromatic. Said the same thing I can say here also. Yes, you can say here also, you see. Said double bond, I can say, okay, no problem, we can say double bond, it's a double bond. Then sir, I can say it's a single bond, okay. Then sir, I am getting double bond, very good. Then you are getting single bond, till this part no problem, but again you are getting single bond. No. So this is also not conjugated. This is also not conjugated. Okay, sir, I understand this thing, but what about the last molecule? The last molecule is looking like this. The last molecule is looking like this, and if you see, it is cyclic, it is planar, it is conjugated. It is conjugated, but the problem is, you see, it's a double bond, single bond, double bond. Okay, these things are there, no problem. But how many pi electrons you are having? How many pi electrons? 4 pi bonds, so that means 8 pi electron you are having. So sir, it is not satisfying 4n plus 2, it is satisfying 4n pi electron rule, where n equal to 2. That means n equal to 2, that means it is not aromatic, it is actually anti-aromatic. So it is not satisfying this 4n plus 2 pi electron rule. So that's why this one is not aromatic. Here conjugation is not there, here conjugation is not there. So this is the reason why these systems are not aromatic. Got it? Okay, then how to convert benzene into this type of question? I just love this type of question. So what they are asking, the first question they are asking, that you have been given with benzene ring, and from here you have to you have to do para nitrobromobenzene. Para nitrobromobenzene means bromine here and the NO2 group here. These questions can be very easily explained if you have the knowledge of ortho para directing group, ortho para directing group, ortho para directing group and meta directing group. If you have a concept about this, then only you can do this, and I have discussed in detail about this, right? Okay, so let's start, sir. Let's start. So I can do benzene ring. Now you see, in between Br and NO2, which one is orthopara directing? Sir, I know that NO2 is the most deactivating group, most deactivating group, and deactivating group means it's a meta directing group. It's a meta directing group. So you see, it's a meta directing group. So if you see that, let me do benzene ring and do nitration. So nitration means you want to do concentrated HNO3 plus concentrated H2SO4 you want to do. Yes, if I do this, then I will get benzene ring with a NO2. No problem with that. So NO2 group I got. And sir, for to get bromine, I can use Br2 FeBr3. This is called bromination or halogenation. The first reaction I am doing nitration, and the second reaction I am doing bromination. But the problem is now, NO2 is a meta directing group. So if you do this, you will get a product, but you will not get your desired product, you will get this molecule. Are you getting my point? So if you go by this sequence, that first nitration, then bromination, first nitration, then bromination, you will not get your desired para product, you will get meta product. But that, sir, I don't want. So this sequence is not correct. So to make you understand this, I have done first the wrong sequence. Okay. Now, sir, what is the correct sequence? So first it is a benzene ring, you do Br2 FeBr3. That means you do bromination. So if you do bromination, you will get bromine. And these bromine things, these halogens, they are deactivating, but ortho para directing. Why? And all these things I have told you detail. I already explained it in detail. Okay, they are ortho para directing group. I have explained in detail. Now bromine, and now if you use concentrated HNO3 plus concentrated H2SO4, you will get two molecule. You will get bromine with a para substitution. Obviously you will get a bromine, obviously you will get a benzene ring with bromine and at ortho position NO2 group. Okay, this is your para product, this is your ortho product, and obviously you know that para is the major one, ortho is the minor one, but still you will get some minor ortho product. So what you have to do next step we have to do separation. Next step you have to do separation, and if you do separation, then ultimately you will get your desired product, BrNO2. So first step it's bromination, then it's nitration, then it's separation. Okay, so these reactions are all about, this is called sequence of reaction. In which sequence you are doing the reaction, that is the thing. You know the reactions, but in which sequence you are using this, that will depict, that will that will tell you which product you will get. Okay, now so next question is meta nitrochlorobenzene. Sir, meta, I know, I got it, benzene to meta nitrochlorobenzene. Now if it is a meta thing, then meta will be, first you have to do nitration, then you do chlorination. Sir, why? Because benzene, from here if you do meta nitrochlorobenzene, how can you get it? How can you get this? Sir, it's very easy. Meta, I have to put the second group at the meta position, so better do concentrated HNO3 plus concentrated H2SO4 right now, because I will get the NO2 group, and this NO2 group is a meta directing group, and for Cl2 I will do Cl2 FeCl3. So I'll get NO2 here and I'll get a Cl here. It's so easy, right? It's so easy. You just have to understand what, like which direction the reaction is going. Para nitrotoluene. Sir, para nitrotoluene. Again, it's the concept of para nitrotoluene. That means a para concept. That means I cannot do nitration at the first step. Toluene is benzene with a CH3, and this is NO2. Para nitrotoluene. Okay, now sir, as it is a concept of para, so I cannot do nitration in the first step, so I have to do that toluene thing. And sir, how can I get toluene? We have discussed about Friedel-Crafts alkylation reaction. We have to do that. CH3Cl anhydrous AlCl3. If we do, I'll get this toluene. Then sir, I will do concentrated HNO3 plus concentrated H2SO4, and if I do this, I'll get benzene CH3 with a NO2 group here. Okay, sorry, let me just write it like this. Sir, I'll get a benzene ring with a CH3 and a NO2 group here, plus I'll get benzene ring with a NO2 group at the ortho position. Obviously the para is my major product and the ortho is my minor product, but still you will get that, so you have to do separation. And you will get your desired para nitrochlorobenzene. toluene. Got it? Now the next question is acetophenone. Sir, acetophenone, I don't know the structure. Yes, you know, we have already done this. Benzene to acetophenone. How to do this? Benzene to acetophenone. You see, benzene is this molecule, right? And acetophenone is benzene ring with a C double bond O CH3. This is called acetophenone. Benzene ring with C double bond O CH3. Now, tell me how to do this. Tell me how to do this, sir. C double bond O CH3, that means it's the acyl group, right? Yeah, it's the acyl group. Okay, sir, no problem. I have to do Friedel-Crafts. I have to do Friedel-Crafts acylation. I have to do Friedel-Crafts acylation. So how you will do that? How you will do that? So take benzene ring. The group you have to enter is CH3C double bond O. Take a chlorine with that and anhydrous AlCl3. Anhydrous AlCl3. I will do Friedel-Crafts acylation. I'll do Friedel-Crafts acylation. This Cl will be taken by this way and this group will go here. I am not doing the exact mechanism, but yeah, you will get this thing, and the name of this is acetophenone. The name is important. The naming is important. So okay, that's it. So like I have solved probably how many questions? Let's see how many questions. 1, 2, then 3, 4, and 5, 6, 7 questions is solved, and I hope you understood everything. And if you are having any problem, you please let me know and wait for the next video. And till then, it's bye bye. You stay happy and healthy and happy studying. Thank you.